Our last unit was exponentials and logarithms. So our first question is, what does the equation of an exponential look like? Y equals, we used a and b, and a lot of times we put the b in parentheses. And a was the start, and b was the growth rate. So when we had the zombies, this is how many zombies we started with, and this is how many were increasing, or how much was it decreasing by. So if it was a 2, it was doubling. If it was 1.12, it was increasing by 12%. Which brings us to, how do I find the percent change from an equation? It doesn't require a lot of work. It's just, you have to look and see, is it growth or decay? And then you have to decide how much percentage did it go up or down. So let's do just some quick examples of each one. So maybe you see an equation that looks like this. In this case, it's growth because it's 1.32. That's 132%. So that means my growth was 32% because it's 32 above 100. And then let's look at a decay. Well, that would be, let's just say it was 4 times 0.81 to the x. In this case, it's decay because my growth rate is less than 1. It's a decimal. It's 81%. But that doesn't tell me the actual change. That tells me how much I'm taking of the original. So if it's decay, I need to see 100% minus 81%, which makes 19%. So the change here is 19%, where this one's 32. And then, can I write the equation of an exponential from, we did a few things. The first one was from a graph, right? So it was something like this. And you have to figure out what is the equation in this form. And then our next one was finding them from 2 given points. And we found that we were able to do that with guess and check sometimes, or other times we had to calculate the b, and we used a table for these. So the table was quite useful, and it was also very useful for when we did it from a word problem. And our word problems were all dealing with money. So we have to figure out how many jumps or how many years went by in our table and use that to find our growth rate. And then how do I change from, so after we did the exponentials, we started moving into logarithms. And when we did that, we started with fractional exponents. And we changed between that and radical form. That, remember, radical means it has a root. So for example, our main one was if it was some number to the exponent of a fraction, and make sure it's the exponent. So don't write it down here, it needs to be up. That is actually telling us, well, this has a fraction, so I know it needs to have a root in it. Now I just have to figure out, where did the n go, the a, and the b? Where do they all go? So this is saying n to the a, but since it's divided by b, that's the root. So the one in the bottom is the one that's making it smaller, and that's going to be the root, so the one that goes on the outside. And then what is the relationship between logarithms and exponential functions? So I'll just say exponentials. If we look at a graph, which we did in class, we found out that they were opposites of each other, and our key word is inverses. They are opposites of each other. This is our key word though. And we also looked at the intercepts. So what is the y-intercept on the graph? Well, we found that the graph looked something like this, and that it got really, really close, but it never actually crossed. So there is none. It does not have a y-intercept. It does not cross the y-axis. And our last main thing was solving exponential equations, and we did, how do I change from logarithms to exponentials and solve? So we combined those two skills together. So let's just do an example for that. So let's say we have log base 9. And then let's just do 5x minus 3, and then equals 2. So we want to solve this for our variable, because we only have one thing there, we don't know what it is. Well, to solve it, I'm going to change it to exponential, so 9 squared So this is my base, and that's where I start. 9 squared equals whatever's over here. Now I just have an equation that I can solve. So I know 9 squared is 81. So I would not move the 3 because I need to simplify my exponents first. Now I just have a regular equation, so I'm going to add 3 to both sides to cancel that. So I get 84 equals 5x. And then I need to divide by 5. And this is just going to be 84 over 5. So if a question said put it in simplest fraction, I can put it in my calculator, or I can just write this because this is the simplest fraction. Okay? And that is it for Unit 4. Good luck and happy studying.